Hello everyone. Let's talk about sleep of a three-phase induction motor. Okay, let's learn it. Okay. Now see, this is what your stator. This is what your simple stator of a three-phase induction motor. Okay. Stator of a three-phase induction motor. Suppose you can also connect yoke likewise, so you will get to know, understood more. Okay. Now this is what the stator, and this is what your squirrel cage rotor of a three-phase induction motor. Now see here. Try to understand, when we are going to provide a supply, what supply? Three-phase AC supply, three-phase alternating current supply. That time rotating magnetic field is going to produce in this air gap, right? See, this we have already learned. Rotating magnetic field is going to produce. Now also we also learn about the working. Now what is happening here? Initially the rotor is standstill, but your stator is providing rotating magnetic field. Now that rotating magnetic field, it will have some speed. Of course it will have some speed. So that speed, that rotating magnetic field speed, which is known as a synchronous speed, we denote it as a NS, synchronous speed. So remember this thing, I repeat it, your rotating magnetic field speed, RMF speed, which is nothing but your synchronous speed, and which you can calculate by the help of this formula, which is 120 F upon P. So F stands for frequency, P stands for number of poles. This you can get it from the nameplate of the given motor. You can find this value over the nameplate of the motor. Okay. So you can calculate any motor's synchronous speed by taking the data of these two. Okay. Now see here, so F is F you already know. In India there is everywhere you can find the F is a frequency which is 50 Hz. But you just have to just check the number of poles. Then you can calculate the synchronous speed. It means the rotating magnetic field speed. Now see, it is rotating. So it is always in RPM. Speed in RPM, revolution per minute. Okay. Now it is moving, it is rotating. Okay, it is rotating at some speed, okay, which is synchronous speed. But initially your rotor is standstill. We already learned it in a working. See, at when it is standstill and it is rotating, it means there is a very high difference. After some time it will start rotating, right? And it will try to catch this synchronous speed. Now remember, this will never going to happen. And it will always lag behind the synchronous speed. It means from start to run, you can see there is always a difference in actual speed. Now this speed, when your rotor start rotating, the rotor speed you can denote it as a N, or you can denote it as a NR, and this speed also known it as a actual output, right? And this is always lagging, right? Which will never going to catch a synchronous speed. That's why there is always a difference, and that difference, now this is actual speed, or you can say rotor speed, that difference you can known it as a slip, which is NS minus N with respect to synchronous speed. So the difference between synchronous speed to the actual speed with respect to synchronous speed, which is known as a slip, we always calculate in a percentage. So multiply by 100. Always remember, you will always have a value of a slip which is always in a percentage. You will never get in any other value. Okay. If you want to calculate slip speed, then it will be only NS minus N. Then you have to put here RPM unit, right? The difference of this will get some speed, right? So you have to give the unit RPM, revolution per minute. But at the motor's nameplate or the data of the motor, you will always find, or you will always get the percentage slip. Getting it? So this is what the slip of your three-phase induction motor. It is nothing but the difference between the synchronous speed to the actual speed with respect to synchronous speed. Okay, and we always calculate in a percentage, that's why multiplying by 100. So this is what the slip of a 3-phase induction motor.